Hello folks, we continue with this exercise 3.2 is a part 4 video. In the earlier part we were finding out the other trigonometric ratios from what was given to us, but now we are doing a bit different thing. We are finding the value, and for finding the value we roughly saw in the problem number 6 as to how to go about doing it. We are going to take the problem number 7, but before that I have a small ready reckoner over here. So let's get ourselves brushed up with it with this ready reckoner and then proceed with the problems. It's very interesting if you understand this. Okay, so let's understand it and have fun out of this and solve the problems. See, we broadly divide this into 4 quadrants, and in these 4 quadrants there are some things that you should know. In the first quadrant, all trigonometric ratios are positive. We have learnt it. So all trigonometric ratios are positive, and any angle in the first quadrant is in the form 90 minus theta or 360 plus theta. It's clear to us. 60. How is 60? 90 minus 30, isn't it? You take another angle 70. It's there in the first quadrant. And how is it? 90 minus 20, right? Or it can be, sometimes it can be 360 plus theta also, when the ray that you're considering, it would have completed one full revolution, and if it comes back it can become 360 plus theta also. So these are 2 forms in which they can be expressed. Now this is the degree measure. Its corresponding radian measure is like this: 90 minus theta, 90 in radians is pi by 2 and 360 in radians is 2 pi. So therefore 90 minus theta can also be called as pi by 2 minus theta, and 360 plus theta can be called as 2 pi plus theta, just the radian measure. Okay, so that is about the first quadrant. Now the moment you go to the second quadrant, the arm would have rotated and gone to the second quadrant, and in the second quadrant every angle, you look at the angles in the second quadrant, how are they? 120 degree, 135 degree, 140 degree, 160 degree. So they are all of what kind? They are 90 plus something, or they are 180 minus something. Like if you have some 120 degree, how is 120 degree? 90 plus 30, or it is how? 180 minus 60, right? So every angle in the second quadrant, they are either of the type 90 plus theta, or they are of the type 180 minus theta. That is how we understand that. And we have earlier learned that only sine and cosec is positive over here. All trigonometric ratios, all other trigonometric ratios will be negative. We are writing its corresponding radian measure, pi minus theta and pi by 2 plus theta. Same thing but in radian. Okay, that is the second quadrant. Third quadrant, only tan and cot is positive, and here every angle is either of the type 270 minus theta or 180 plus theta. It's clear. Suppose if you have some angle like some angle like 250 degree. How do you have 250 degree? It is 180 plus 70, or it is 270 minus 20. That is why we say that at every angle in this quadrant, they will be either of the type 270 minus theta, or it will be of the type 180 plus theta. And then we write its radian measure. See, 270 in radian is 3 pi by 2, and 180 in radian is pi. So that way we have written the conversion over here. That is the conversion. Last quadrant, where we have only sec and cos positive, and there every angle we know it has left 270 and gone that side, and it is beneath 360. That is why it is 270 plus theta or 360 minus theta. Both ways it's okay. And here only cos and sec are positive. For 270 the radian is 3 pi by 2, and for 360 the radian is 2 pi. So it's corresponding in radian or in degree. So this you have to understand, and in the previous question also I had told you that it's better if you know these multiples, your work becomes easy. Now in this exercise we will also use another shortcut, that if you have sine of minus theta, you can always call it as minus sine theta. If you have cosec of minus theta, you can call it as minus. That minus inside, no, it will create a lot of disturbance. Let's pull it out, and then your working becomes simple. See, this tan inside, that minus theta, maybe it will create trouble. So let's take that out and then let's work. So it becomes very comfortable. Then like that. So you know this. See, everywhere the minus comes out, and that's how you work, except for cos and sec. No, for cos and sec, the minus vanishes. Cos of minus theta becomes cos theta, and sec of minus theta becomes sec theta. The minus just vanishes from the angle. The negative part vanishes. So if you can take all this in mind, the working becomes very simple, and you can do the work very easily. So we are taking up the problem number 7, which is cosec of minus 1410. Right away we are applying this. The minus, as I said, is going to create maybe a little disturbance. So let's take it out directly, and we can always write it as cosec of minus 1410. And I said that we are never going to be afraid of these angles because we have learned the technique of expressing it in terms of a multiple of 360. Because we have learned that, we are going to be very confident and we are going to do this. What we are going to do is, instead of writing 1410, there is no harm if I write it as 1440 minus 30. Mathematically it is correct. Instead of writing 1410, I wrote it as 1440 minus 30. Why I do this? There are two advantages, as I said. One is that this is a multiple of 360 and the other is that 30 is a standard angle whose answer we always know very easily. So that is why we have used this conversion. Now, we are able to use this only if that multiple is clear in our mind. We are able to use it very fast. Okay, so now this is now 360 into actually 4. So it behaves like 2 pi only. So actually what kind of angle is this? This is of the type, the angle is almost of the type 360 minus theta. Okay, multiple will, as I said, always behaves like 360. So it's like 360 minus theta if you observe this. So if there is an angle like 360 minus theta, in which quadrant does it lie? It lies in the fourth quadrant. 360 minus theta is lying in the fourth quadrant. And what happens to every angle in the fourth quadrant? In the fourth quadrant, only sec and cos are positive. So every other conversion that you do will carry a minus sign. So we are going to convert. Whatever that you convert, there is going to be a minus sign because this cosec is not in its quadrant. It is a guest in some other quadrant. Cosec's quadrant is 2. And it is not in 2, it is in 4. So it's a guest there. Because it's a guest there, it has to carry the negative sign. So let's have the negative sign. Then we will go for the simplification. What do we do in the simplification? We drop this part and we write only this part, isn't it? That is how two things that you have to do. First is decide the sign and then simplify. So we have decided the sign. Now we are going to drop this part. We are going to write only this part. So it is going to be cosec 30. This is how we are going to solve it. Now, luckily for us, this minus into minus will become plus and you are left with only cosec 30. Cosec 30, either you know it directly or you take the reciprocal ratio of sine. Sine 30 we know is half, so cosec 30 is going to be 2. That is how this angle becomes 2. Very, very interesting if you have the steps ready in our mind. We can take one more problem, the problem number 8, which says that it is tan 19 pi. Now we go to the radian measures. 19 pi by 3. Tan 19 pi by 3. Now here also there is a word of caution that you should exercise. Here, as I said, we should always look out for multiples of 360 and try to express it and try to get this part also in standard form so that your work becomes easy. Same way, when you are writing this radian measures, you should see that in the numerator you should try to get a multiple of this denominator. You should get, and as far as possible, even multiple of the denominator so that your working becomes simple. For example, writing this 19 pi by 3, there is no harm if I write 18 pi plus pi by 3. There is no harm. 18 pi, why we have chosen 18 pi? Because 18 pi is a multiple of 3. 3 into 6 pi will give you 18 pi. That you should keep in mind. Try to take a multiple of 3 in the numerator. So when we try to see, we are getting 19 pi can also be, there are other multiples also, but you should try to make this part as small as possible. Then only you will get the simplified answer. So we try to take, see, you could have taken 12, you could have taken 15, you could have taken other values also. But in that case, this part will not be so simple. So you have to try to make it as simple as possible. That is why we have chosen 18 pi. So now 19 pi, we have written it as 18 pi plus pi by 3. Let's further solve it. We can always write it as 18 pi by 3 plus pi by 3. What is the advantage? This becomes tan, this can cut. This will become 6 pi plus pi by 3. Now, same like what we did there. 6 pi is 3 into 2 pi. No, once you get a multiple of 2 pi, then it is almost like 2 pi. The trigonometric ratio will behave like 2 pi. 2 pi means 360. See, so what has happened is, this is almost going to behave like 2 pi. You can treat this as 2 pi plus theta. How is the angle of what type? 2 pi plus theta. You have to classify, where does this angle lie? Any angle of the type 2 pi plus theta, where does it lie? Just look at this chart. It's very clear that 2 pi plus theta lies in the first quadrant. beautiful, because first quadrant will not create disturbance of sign, all are positive. So this is lying now in the first quadrant. In the first quadrant, all trigonometric ratios are positive. So the sign is going to be positive. And now first we, as I said, we'll decide the sign, then we'll tell the angle. Now sign we have decided it's positive. Now we have to simplify the angle. How do we simplify the angle? We drop this part and we only keep this part. That's all. So you have tan pi by 3. The whole thing is simplifying and it is becoming tan pi by 3. So whenever you have this 2 pi coming into picture, we do this kind of simplification. We drop the 2 pi and we only keep this into the picture. So you are getting tan of pi by 3. Tan of pi by 3 actually is tan 60 for us, and that way we can get what the answer is, and tan 60 is root 3. So the value that will come will be root 3. So tan pi by 3 is root 3. We get the answer as root 3, and this is the value. So there are remaining 2 more problems that we will be taking it up in the next video. Thank you.